assignments you haven't done, you want to complete them late, totally fine, just come talk to me. All right, chapter 7. So here is where we really start to get to use those cost curves that we learned about in chapter 6. But before we start to use them, before we get back into graph land, we have more definitions to get to. So in chapters 7 through 9, we're going to have 4 market models, which are just that. These are models of how certain markets or industries work. And the 4 models that we are going to be looking at, we've got the one that we're going to be looking at today, pure competition, which entails a large number of firms a standardized product and probably the most important one, easy entry and exit by new and existing firms. So those are our 3 overarching definitions of pure competition. Now we'll come back to this when we talk about pure competition in more detail in a bit. B. At the opposite extreme, lies this thing called pure monopoly. So they added this pure thing because it actually used to be perfect competition and then just monopoly. But I think the fact that they're at opposite ends of the spectrum, that's why they're trying to do pure, if that makes sense. That's the new terminology. So it's either, pure monopoly or, oh, I did that in the wrong colors again. My brain is backwards. Or pure competition. All the way at the other end. And then the other ones are going to lie somewhere in the middle, right? Makes sense. So at the opposite spectrum, pure monopoly talks about one single firm that is the sole seller of a good or service with no close substitutes. So, if you don't live on campus, odds are you pay for electricity through Nebraska PPD, right? Public Power? I have no idea. I pay them every month, but I don't know their acronym. But NPPD, right? It's the electric company, right? I don't have a choice. I can't decide to go to a different electric company, right? Just like if I wanted different cable internet, I couldn't go to a different place besides Great Plains. I mean, there is a little bit of choice there. I can go for DSL, which is slower, right, and not as good. But that's neither here nor there. So there's no close substitutes to our utilities, to broadband internet service, to advanced medical treatments, right? So these things are these pure monopoly goods. Now, what's in the middle here? So in the middle, we've got the thing that's closer to pure competition is called monopolistic competition. Kind of annoying. They just cram those 2 words together. But there's a reason for it. So this is close to pure competition. Except the product is what we call differentiated. So instead of it being normalized, instead of it being a standardized product, which is what we have up here, right? A standardized products. And when we think of standardized product, we think of ears of corn, we think of bushels of wheat, right? Like it's not like we're going to the store and we're like, oh, I want that good corn from this farm, right? Like corn is corn, right? It's a standardized product. But, for shampoo, for other kinds of things, for clothing, right? Partly because we have these tastes and preferences, partly because advertisement, partly because of the people around us and what they're doing, right? We end up buying certain things over other things, those differentiated goods. So rather than standardized, and then also there's fewer firms. Good use of fewer there. We'd be tempted to say less, but that'd be grammatically incorrect. Fewer. All right, so monopolistic competition goes right here. Mono-comp. So it's almost competition, but there's branding, there's differentiation, there's less firms, there's none of this easy entry and exit, right? So pure competition, it's very easy, it's very cheap to get into, right? If you wanted so like pure competition would be something like, tutoring or car washing or something like that, right? It's like, what do you have to, get in order to start it? Like a bucket and some soap and some sponges, right? And then you just like got to go bribe somebody so they use their parking lot when they're not using it, and be like, hey, I want to wash cars for blank reason, right? So the last one that we have, so monopolist competition, pure competition, the last one that's somewhere in the middle here, I would actually get it closer to pure monopoly. And this is an oligopoly. So, oligopoly. Kind of spelled like monopoly, oligopoly. I'll scroll up for the people in the back. Just want to make sure that you get this number, or not number line, but you know what I mean. So an oligopoly is an industry or market in which few firms exist. So the main defining aspect of oligopoly is that each firm is affected or impacted by the price output decision of its rivals. So we will get to this later on. The biggest oligopoly that you may have heard of if you're, following the news at all, right, is OPEC, right? It's the world's largest cartel. It's all the oil-producing nations in the Middle East, and they get together and they say, well, let's only release this many barrels, because they know supply and they know the law of demand, right? If they decrease the amount of stuff that's out there, the price is going to be higher. People are going to bid the price higher. And now we're actually seeing oil above $80 for the first time in 3 years, which is, we all know this because we see it at the pump all the time, right? So the oil industry, for the most part, is an oligopoly. Now, there's been a lot of, exploration and fracking and shale and all that kind of stuff, right, to break up that oligopoly. But that's not without its, consequences, right? So, yeah, again, we'll get to that later on. But today is all about pure competition. So you'll also see this known as perfect competition if you look on the internet. So what are our characteristics of pure competition? So the first one that we talked about is that many sellers notion, right? So why does this matter? Well, it means that there are enough firms so that so that a single seller, even doesn't make sense there, has no impact on price by its decisions alone. So this is called, they are price takers. You got certain industries that are price makers, right? The PlayStation, the Xbox, they say, you know, this is how much games are and this is how much the console is, right? And the consoles are actually loss leaders, right? They actually don't make a lot of money on the consoles, but they make a lot of money on the games and on the monthly membership and all that other kind of stuff, right? But still, nonetheless, right? They are able to set the price for whatever they want, and there's not a lot of competition. That'd be an oligopoly, right? PlayStation and Xbox, it's an oligopoly of gaming. Yeah. So the products in a perfectly competitive market, the products are standardized or also homogeneous. So homo from the Greek root same and genus of the same type, right? So they are all standardized. Each seller's product is identical to the competitors. We've got freedom of entry and exit. What does this mean? This means there are no significant obstacles from preventing firms from entering or leaving the industry. So pure competition is actually very rare in the real world. But, so you're like, so why are we learning this? But the model is important. So why is it important? Well, the model helps analyze industries with characteristics that are similar to pure competition, like monopolistic competition, right, which we'll get to. It provides a context in which to apply revenue and cost concepts that we talked about in previous chapters. And it's a simple context compared to the other ones. And then lastly, it's going to be a norm or standard against which to compare and evaluate the efficiency of the real world. So this last point here, not really going to become apparent till we get to the model and we get to kind of what happens in the long run of the model, right, as firms enter and exit the industry, how that impacts the individual decisions to shut down or not. So we've got 4 major objectives. We're going to examine demand from the seller's perspective, see how they respond to market price, look at the long run objectives, and then evaluate the efficiency of those competitive industry. So let's go ahead and jump right in. So this is demand as seen by a perfectly competitive seller. So it's important for us to keep in mind that the demand curve still exists, right? The industry demand curve still exists. It's still downward sloping. But the demand curve that the perfectly competitive seller sees is going to be perfectly elastic. So what do we mean by perfectly elastic? We can take a look at figure 7.1 in the text. Figure 7.1 talks about how essentially, so think about Walmart. Put yourself in the perspective of the general manager of Walmart, they're actually really nice people. LMNOP, QRS, right? So let's say that I'm selling DVDs. So from the perspective of Walmart, and let's say DVDs are $10, right? That's probably how much they are. If Blu-rays, it'd be like 30, but we're just saying DVDs. So DVDs, they're going to be $10. So how much are you going to get if you sell one DVD? You're going to get $10, right? How much are you going to get if you sell 10 DVDs? You're going to get 10 times $10, right? So instead of having an upward-facing demand curve, essentially it doesn't matter how many DVDs you sell. Sorry, they should all be on the line. Herp derp. It doesn't matter how many you sell. Your marginal revenue is still going to be the same. Now, this doesn't mean that you don't have an upward sloping total revenue curve. You still do. Your total revenue is still increasing every time you sell something. It's just that the price at which you sell it does not change, right? We're price takers. So a couple of definitions that we have to get out of the way before we can move on. So the first one is average revenue. And this is the price per unit for each firm in pure competition. Next is our total revenue. Is just that price multiplied by my quantity that's actually sold. So it doesn't matter if I produce them, it doesn't matter if they're on the floor, right? That's just part of inventory. I've got to actually sell it in order to get my total revenue to increase. And then lastly, right, this is where we're going to spend a lot of our time because economics is all about incremental or marginal analysis, right? So marginal revenue is the change in total revenue divided by the change in quantity. Now, for the most part, the change in quantity is going to be 1, right? It usually has the change in quantity be equal to 1, but that's not always going to be the case, especially on Connect. Sometimes it goes up by 5, 15, right? So you just have to make sure that you divide by the change in quantity in the denominator, right? So we could also look at it as the change, so this delta symbol here means change in math, in total revenue over the change in quantity. All right, so definitions out of the way. Let's go ahead and actually put some stuff together. So in all of these different types of economic forms, they're going to be doing what? They're going to be profit maximizing. And then this is in the short run, and that'll become apparent, that'll become important later. Don't worry about it too much. We know that the short run just means that something is fixed, right? There's the size of the plant or the building is fixed. The number of ovens in the pizzeria is fixed. So we have to answer 3 questions. There's always these 3 questions, these 3 same questions that we're going to answer. So the first question is, should the firm even produce in the first place? Seems like a silly question, but there's a reason why. We'll get to it. If so, how much? Are they just going to produce as much as they can? Or is there some sort of level that is going to maximize their profit? And then third, what will be the profit or loss? So let's go ahead and figure 7.2 is what we're going to use in terms of my rough approximation. On page 170 of the text. And so it's got a table here with all the actual amounts, which we can go through, and maybe we will with some actual problems at the end of the chapter. But for the moment, to keep momentum going, we're just going to power right through and go with the graphs, because the graphs is really where the intuition lies. So this is the price. Now this is kind of not a great, it's actually more of our costs and our revenues. So yeah, it is price, right? But probably better off putting a dollar sign there than price. And then quantity, which, is going to be our output. All right, so we have an average total cost curve starting off somewhere around here, and it goes down, and it makes this U shape. We've got a marginal cost curve that does some guy like this, Nike swoosh, but it has to go through the very bottom. It's kind of the bottom. So why does it have to meet at the very bottom, right? Well, again, if we think about any kind of position before this point, right? What does that mean? What's actually going on in the graphs for this range of stuff, right? So I'm right here. My average total cost at this point, so my output is 4. My average total cost is $100. And my marginal cost at 4 is, it's around $60. So am I going to go ahead and produce that, or sorry, if I produce that 4th unit, is that going to lower or raise my average total cost? Well, since the marginal cost, since the cost of my next thing is less than, right, it's 60 compared to 100, it makes sense that this value, this marginal cost, is still below the average total cost. And so the same thing when we have 5, right? When we're at 5, the average total cost is like 98, and the marginal cost rises to about 75. So there's a reason why I keep drawing this marginal cost curve so meticulously and make sure that it goes through the very bottom of that average total cost, because it's tautological. It's just by definition. There's no other way to draw them that correctly. And so the same thing happens on the other side, right? All right, let's see how much I can stretch the undo feature. I need to get really good at copying things or something, and then like breaking out and then messing with it, and then having like a, yeah, that's my limit. All right, good to know. All right, can I unhighlight? Not easily. Good to know. Won't be using highlighter again. All right, so we have another curve in here. Well, we actually have two, right? So let's go ahead and just draw them for completeness. Our first one is our average fixed cost, right? So in our example here, our fixed cost starts out at 100, and it just gets smaller and smaller and smaller. And then remember, this distance here should be exactly equal to the distance between the average total cost curve and my average variable cost curve. And I'm not going to draw it the best, but there it is. All right. Yeah, that's actually pretty good. It kind of matches up, man. So, like I said, we're putting it all together, right? We're putting together our marginal revenue and our average total cost, right? So just this part, just the marginal revenue part. We don't care about this total revenue part, all right? We're just going to take this graph, figure 7.1, and we're going to overlay it on top of figure 7.2. And so here we're told that the price is $131. So this is my marginal revenue, and this is equal to my demand curve for that firm. So again, we still have the downward sloping demand curve for the industry proper, but we have a flat, completely elastic, horizontal marginal revenue curve or demand curve for these perfect competitions, right? Doesn't matter how many they sell, they always just get $131 per unit. So given this picture, what's going to happen? So here's where we get to our golden rule of economics, and if I had a better gold or something, I would do it in like sparkly gold print, but I don't. We're going to produce all the way, so our Q star is where our marginal revenue is greater than or equal to our marginal cost. So this is our golden rule. This is our MC, MR equals MC. It's our, what exactly do they call it? Just equilibrium, I guess. But it's used a lot. Oh, they just call it the MR equals MC rule. We need to get a better name for that. That's a silly name. The MR equals MC rule. And really, it's MR greater than or equal to MC, because sometimes you can't produce 1.33 cars, right? And so you just produce the last whole unit where the marginal revenue is greater than the marginal cost. So for this one, we ended up with a marginal revenue intersecting with the marginal cost all the way over here at 9 units. So let's talk about how we got to this point. So number one, we just need to find where the marginal revenue and the marginal cost curve meet. But there's also some intuition there, right? So I wish I could just move this highlighted portion up here, because now we're going to do a similar thing over here. So over here, right, if I was at, let's say I was at 6. So any place to this area, we're going to talk about this now. So any place to the left of that equilibrium point, what's going on there? So let's say that I was at $6, or 6 output, sorry. 6 output, or 7. Let's say I'm at 7 output. At 7 output, my marginal cost, the cost of, okay, so I'm at 6, and I'm deciding whether or not to, you can turn that off, yeah. I'm deciding whether or not to produce that 7th unit. So that 7th unit is going to provide me a marginal revenue of $131, right? So if I'm at 6 and I'm deciding whether or not to produce that 7th, that extra unit is going to give me $131 extra. And it's going to cost me a lot less than $131, right? It's going to cost me something like $110. And so am I going to go ahead and produce this 7th unit? You bet your butt I am, right? Now what about that 8th unit? Well, that 8th unit, there's a similar thing happening, right? Our marginal cost is increased. Our marginal cost at unit 8 is now, 125. But, 131 is still greater than 125, right? We're still making $6 by producing that 9th thing. So we're going to go ahead and produce all the way up to 9, because 9 is that Q star where my marginal revenue is equal to my marginal cost. So this is the thing that's going to give me the greatest amount of profit. Now let's go ahead and I'm just going to real quick redraw this so we can draw the profit square. So see how fast I can do it. 3109. All right, so now our profit square. So here is our Q star, right? So we know that our total revenue is equal to what? P times Q, right? The Q sold, which is our Q star here. So our total revenue, in other words, is this whole rectangle here, right? If we just multiply the quantity by the price, that rectangle, the area of the rectangle, that's our total revenue, right? Graphically represented. Now, where are our total costs? Our total costs are from wherever, so we know that our total costs is equal to our average total costs times our quantity sold. Now, how do I know this? Zoom in a little bit. Well, I know that my average total costs, right? Anytime there's average, I'm just going to take the total cost and divide it by quantity. So now let's go ahead and let's substitute this back into this original equation. And I end up with total cost is equal to total cost over Q times Q. So this Q annihilates itself, and we end up total cost equaling total cost, right? So that's how I ended up getting this right here. You don't need to know how to get it, but for some people it helps instead of memorizing to just understand why things are the way they are, right? So total cost is our average total cost times that quantity, right? So this is the quantity. Here's my average total cost curve. So this whole rectangle here is my total cost, right? So what does that leave me with? That leaves me with my profit square, or my profit rectangle, sorry. So this green highlighted section, all the way down to the average total cost, this is my profit. This is how much I am making above and beyond my costs, including my opportunity costs, right? We're talking about economic profit and economic costs here. So you're recouping all of your foregone entrepreneurial income, all of your foregone interest on the money that you might have invested in the company, right? All that kind of stuff. And you're getting these abnormal economic profits. So we call them abnormal economic profits. So we'll get to why we call them abnormal in a sec. And so the math here, right? We know that profit, which is it's symbolized by pi. So profit is equal to total revenue minus total cost. And so profit is equal to price times quantity minus average total cost times quantity. We've got like terms in each one of these, or sorry, we've got, like Is that what it's called? Like terms? I thought each one is called a term. I need to talk to my math buddy, Gregory Moses, and ask him these pressing questions. And so we have like terms, so we're going to pull that Q out of both of them. And so let's go down here. We end up with profit equal to quantity times price minus average total cost. And that is essentially what we've got here, right? What is this here? That's the price minus average total cost. And then this quantity here is just this quantity right here. I do love my arrows, looks like. Big part of how I take notes, apparently. All right. Any questions on this? So it's very important that we understand the intuition behind this marginal revenue equals marginal cost curve or rule, right? So we're going to produce up to that point because that's going to get us the greatest amount of profit. What if we produced at, so we knew that this was 9, right, from the last example. Just for, giggles, right? What if we produced at 8? What if we stopped at 8? Well, then we would end up, and I know I'm getting a little crowded over here, but then we would end up producing, or sorry, that's actually way too much because I don't want to do that lesson quite yet. We'll get there. So something like this. So that's 9. Let's say that's 8. So let's say I produced 8 instead. So again, I'm going to produce I'm not going to produce at the marginal revenue equal marginal cost because I'm trying to show a point. Okay, so I'm going to produce 8. So this is going to be my marginal cost. Actually, doesn't matter too much. This is going to be my marginal revenue. That's how much I'm actually getting for it, right? That 131 times 8. And then this is going to be my average total cost. So you see that there's this bit of profit that we're giving up when we produce 8 instead of using that profit maximization rule, producing where the marginal revenue equals the marginal cost, and producing 9. Okay. Boop, boop, boop. So, what if the price falls to $81? So this is figure 7.3 in your text. So all of this is in your text to review with some alternate explanations if you are having difficulty. So please take a look there if you want. But it's also really good to just get in the habit of drawing these curves because you will be drawing them a lot. So this one we are going to be drawing our average variable cost curve. For reasons that we will talk about in a second. And so we used to have the price being up here, right? $131. Now we have the price at $81. So at $81, this is my marginal revenue curve, or my individual demand curve, because we know the demand curve for the whole industry is still downward sloping. So we're still going to produce, we're still going to have that rule, right, where we produce Q star at MR is greater than or equal to MC, right? We still have this MR-MC rule in place that's still going to maximize our profits, or, and this is the flip side of it, minimize our losses. So we're actually going to have a loss here. I don't know if you can see that, but if we produce right where this marginal revenue equals marginal cost, that's going to be 6 in our example in figure 7.3. And at 6, right, 6 times 81, I'm getting $81 there. I'm getting a total revenue of, I should know that, but whatever 6 times 81 is. And then my cost is above it. That's the issue, is that my cost is above $81. My average total cost curve when I'm at 6 is 91.67. That's how you know it's coming from real numbers. This is that ugly number there. So this is 91.67. And so this little sliver here is not our profit square, but actually our loss profit rectangle. Man, will I ever stop calling it profit square? This is our loss rectangle instead of our profit rectangle. So, why is this important? Well, at this point, we're actually going to we're still going to produce. So remember we had those 3 questions. Are we going to produce? If so, how much? What's our profit going to be? So at this point, if the price falls to 81, to below where that average total cost curve is, we're still going to produce. Why are we still going to produce? Well, we have $100 in fixed cost, right? My total fixed costs are equal to $100. So what does that mean? If I shut down today, I am still losing $100 every month or every week or whatever it is, right? Now, if I were to go ahead and produce at that point where the marginal revenue equals the marginal cost at 6, I'm going to get a loss of $64. Wait, hold on. Yep, a loss of $64. So this loss rectangle is equal to $64. And so the way that we calculated that, same way that we calculated the profit rectangle, price, now instead though, no, it's actually going to be the same. It's going to be, sorry, quantity, price minus average total cost. And so our quantity is 6, our price is 81 minus 91.67. 6 times 1.67 is apparently 4. So we end up with 6 times 10.67. So yeah, 6 times 0.67 is 4, 64. So if we're losing $64 here, and the alternative is to produce 0 and losing $100, the loss of $64, right, is actually preferable because negative 64 is greater than negative 100. So you're going to be able to cover all of your variable costs. You're going to be able to pay all your people, and you're going to be able to cover some of the fixed costs. So you're going to stay in operation. You're still going to produce even though you're losing money. So this is the loss minimizing case. Whereas the last one was the profit maximizing case. Now let's go ahead to the shutdown case, which is figure 7.4. In page 173 of the text. Do better than that. So now if our price falls down to $71, so here's an annoying thing. We kind of ignore this part of the marginal cost curve. So in a way, you can just think of it starting down here. Because you would be tempted to be like, oh, there's 2 There's two profit optimizing. There are not. So just in a way, ignore that first part of the Nike swoosh. So here we're going to go ahead and we're going to do our same rule, right? We're going to pick our Q star where the marginal revenue equals the marginal cost. Why are we doing this? Because that is our profit maximizing or loss minimizing situation always. Now let's evaluate what's going on in this situation. Well, in this situation, I have got costs of, what are my costs? Almost $100. And I end up getting $71 from each sale. And so, and my Q star at this one is 5. So when I calculate my profit, it's going to be 5 times 71 minus 100, right? Which we already know. That's 29 times 5, which is 30 times 5 minus 5, right? So that's 145. We already know that this is, so this is our, and this is negative, right? This is our loss. We already know that this is greater than our total fixed cost, which is negative 100. And so as a result of this, this is our shutdown case. Shut it down. So let's talk about what happens over time. So if a firm shuts down, what does that mean to the industry supply and demand curve? If this is Tina's wheat, and this is the wheat market, we know that the wheat market still has a downward sloping demand. It might be not very downward sloping. It still has a downward sloping demand. And we also know that the wheat market has an upward sloping supply curve. And so what is one of our determinants of supply? It's what? Factors of production, right? The cost of things, price of complementary goods, price of substitute goods, substitutes in production, complements in production, rather. The weather. This last one. What's one related to what we're doing right now? If firms are exiting the industry, what does that do to the number of firms? Decreases them. Number of firms is one of our determinants of supply. So that's going to shift our supply curve inwards. So essentially, anytime a firm exits the industry, oh, and I did a really poor job of matching this up with the other graph, didn't I? Let's just start it over real quick. I'm going to do the same thing, but then I'm going to match it up a little better. Got too busy talking, not drawing. All right, so let's make this guy around here. I like the pink. Do this. Do upward sloping supply. Boop. Call it S naught. That ends up, see, this ends up making our equilibrium price, right? Since they're price takers, whatever that price is, ends up being the individual demand curve, the individual marginal revenue curve for that firm. So then, when somebody leaves the industry, that shifts my supply curve to the left. And let's say it shifts it a bit. Until we're at this point where there's no more incentivization to enter or exit the industry, because it'll tend to, so essentially firms are going to exit the industry and there's going to be movement of the price. So there'll be a movement along the demand curve until we get to some price which corresponds to the bottom of the average total cost curve. And this is essentially where pure competitions end up, they tend to. So this is like my long run marginal revenue or long run demand curve. So it's always, there's going to be there's going to be pressure. People are going to leave the industry when they're making these losses, right? They're going to leave the industry, and that's going to put upward pressure on the prices until the point where there's no longer abnormal economic profit. So right here, there's zero economic profits. But here's where it gets a little confusing. I used the term abnormal economic profits before to emphasize that anything positive is abnormal. And so we'll talk about like why that's important. There's freedom of information in pure competition, so you can't like hide the fact that you're making a butt ton of money off wheat, right? Like your neighbor's gonna be like, oh look, they're making like they just remodeled their house and got, you know, like new 4x4s or whatever, right? Like we should be planting whatever they're planting. So there's free information that's going to help people leave the industry and also enter the industry until the point where you no longer have any abnormal economic profit. So does this mean I'm still having a positive accounting profit? You betcha, right? I still am making maybe $60,000 of accounting profit, right? That's my opportunity cost. That's how much I could be making if I wasn't managing Tina's wheat. Let's say I'm Tina, right? If I'm Tina Turner, that'd be awesome. And you know, if I was managing this, then I just lost my thing with Tina Turner. What was I saying? Just got thinking about Tina Turner. If I'm selling this wheat, I'm making the money. I'm recouping that salary, that $60,000. So the accounting profit's still positive, but that's the $60,000 is the opportunity cost of my time. It's part of my economic costs, not my accounting costs. So that's why we have a zero economic profit. But remember, still a very, and I know it's stupid to say very positive, it's like somebody's very pregnant, right? But a very positive accounting profit. So let's talk about the example. So we just talked about the example where, as a result of people leaving the industry, there was an increase in the price until we got to some sort of equilibrium where there's zero economic profits, right? So, you know, everybody's losing money. They're losing $145, and you know, instead of $100, so they say, I'm getting out of this. I'm just going to eat the $100 a month for the rest of my lease and go do something else, right? So, but what if the situation were different? So I think, no, that one's too crowded. Let's just redo. Let's go redo a new guy. So if this is the situation that I find myself in, right, and I'm Tina's wheat, I have abnormally large economic profits to the tune of whatever this area of this rectangle is, right? Oh, I shouldn't write stuff over here. So this is where some of those assumptions questions about perfect competition markets come into play? And that's green. We've got a similar thing. Here's our demand. Here's our supply. Oh, I drew this all wrong. There we go. That's better. Gives me plenty of room for us to expand in terms of entry. So there's two main things that are happening here, right? We've got freedom of entry and exit in the industry, and there's free information, right? So other people are going to see that I'm making this abnormal economic profit, right? So I'm making, on top of my 60,000 that I'm making, right? I'm making an extra 100,000. That's what this abnormal economic profit is. It's saying that I'm recouping my lost wages and then some, right? And so people are going to see this and they're going to be like, oh man, I got to get out of growing potatoes or whatever. I got to grow wheat, right? So that is a shift outwards of the supply curve. And this is going to happen until we end up at a price where there's no more incentive for them to enter the market. And that price is at the bottom of that average total cost curve. So this is my marginal revenue long run or my demand long run for the individual, because that's where, because essentially market forces are incentivizing people to join this industry, and when more sellers join the industry, it pushes the price down. There's downward pressure on prices from this initial high price until we get to a price that there's no longer any abnormal economic profits, right? Because when we're here, we're family. Now, when we're here, the economic profits are zero. All right, so we can cut it here for today. That's really chapter 7 in a nutshell. I mean, like I said, I skipped over some of the numerical stuff, but you guys look pretty glazed over, and so doing some extra problems I don't think is going to help us too much. So I'm going to go ahead and I'm going to stop this. I'll throw it up on YouTube. I'll take attendance, and then you guys can leave.